So this week we are going to have the Prelab sessions for experiment 1, measurements and uncertainties. So measuring some physical quantity is part and parcel of any physics experiment. It is important to realize that not all measured values are the same as the actual value. This could be due to the error that we make during the measurements, or perhaps the apparatus that we use might not be accurate or sensitive enough. Therefore, as a rule, the uncertainty of the measurements must be taken and it has to be recorded together with the measure value in any physics experiments. So for any measurements, we are going to have uncertainty, or what we call as doubt of measurements. For example, let's say you are trying to measure the length of the leaf. The ruler have a resolution of 0.1 centimeter. Resolution is referred to the smallest increment on the measuring instrument, or sometimes we call it as the smallest division of the scale. So what would be the length of the leaf? You are sure the leaf is at least 3.5 cm. You are pretty confident on that. But as you can see, the end of the leaf is not exactly at 3.5 cm mark. We cannot really tell in certain the length of the leaf is 3.5 cm. So we are going to estimate the length of the leaf. We estimate is about 3.5 cm. The reading is actually between the interval of 3.5 cm and 3.6 cm. This interval is what we call as uncertainties of the measurements. So how we are going to report the length of the leaf? We are going to write the length of the leaf will be 3.5 plus minus 0.1 centimeter. So when other people see this reading, they will know that the value is estimated closest to 0.1 centimeter. So the 0.1 centimeter here is what we call as uncertainties of measurements. So, boys and girls, when we reporting the measurements, we will write the value of measurements as our best estimate plus minus uncertainties. If x is the measure value of the physical quantities, the value of x is written as x plus minus delta x. The delta x is referred to the uncertainties of the value for x. So, every measurements we make in experiment have some degree of uncertainties. As we shown before, the uncertainties is due to the limitations or the smallest divisions of our measuring instruments. Then, we can calculate the relative uncertainty by taking the uncertainty delta x divided by the value of the measurements x. The percentage of uncertainty will be delta x over x multiplied 100%. So for different measuring instruments, they might have different sensitivity. For example, micrometer screw gauge can be measured up to 0.01 millimeter, and vernier caliper you can measure up to 0.002 centimeter. So the reading obtained will be more precise with lower uncertainties. So as a conclusion, uncertainty will tell about the quality of a measurements. How to determine the uncertainty of measurements? It will depend on its type and how it is done. So basically, in every measurements in physics experiment, we might have single reading or we are doing repeated reading. So for single reading, to know the uncertainties of any instrument, we need to know two things. We need to consider two things. First, what is the smallest divisions or the sensitivity on the instrument scale? Second one, what are the methods of reading instruments? So basically, there are three methods of reading. First, when we read at a single point on the scale, then our uncertainty will be recorded as half of the smallest division from the scale. The example of measuring instruments that we always read at a single point on the scale is thermometer, ammeter, voltmeter, or protractor. So, for example, I have an ammeter and I can see obviously In between 0 to 1, there are 10 divisions. So the smallest divisions will be 1 over 10 equal to 0.1 ampere. So I'm going to read off at one point. So the uncertainty will be half of the smallest divisions, 0.1. So the uncertainty will be 0.05 ampere. So how I'm going to record down the reading shown by this ammeter? So I'm going to record the current I will be 1.15 plus minus 0.05 ampere. So I can read up to 0.05 ampere. So the percentage of uncertainty can be calculated by taking the uncertainty divided by the value measure. So it will be 0.05 divided by 1.15 multiplied 100%. So I get 4.35%. Another example. For example, I read at a single point on a thermometer. So the smallest division will be 10 divided by 10, 1 degree. So the uncertainty delta X will be half of the smallest divisions, which is equal to 0.5 degrees Celsius. So the temperature shown by this thermometer, I can record it as 23.0 plus minus 0.5 degrees Celsius. So the decimal place for our measure value must be consistent with the uncertainties. So 23.0 will be our measure value, 0.5 will be the uncertainties. So the percentage of uncertainty can be calculated by taking the uncertainty 0.5 divided by the measure value 23.0 multiplied 100%. So the percentage of uncertainty for this reading will be 2.17%. And the second method to record the uncertainty is if the reading is taken at 2 points on the scale, whereby we need to manually line up to 0. For example, when we use meter rules. So normally we require an initial setting whereby we need to align the item we measure one end with the 0 mark, and then we read off at another end. So for this case, we are going to make twice. So there will be twice time we are done of our measurements. Okay, so the smallest division for meter rules is 0.1 centimeter. So for a 2-point reading on the scale, the uncertainties delta X will be 2 times of half of the smallest divisions. So the uncertainty here will be 0.1 centimeter. So I'm going to record down the length of the pencil as 5.4 plus minus 0.1 centimeter. So 5.4 is the reading that we measure. 0.1 will be the uncertainties. So if our apparatus have vernier scale, then the uncertainty will be referred to the smallest scale on the vernier scale. For example, for vernier caliper, we might have uncertainties of 0.1 mm, 0.05 mm, and 0.02 mm, depends on what type of vernier caliper is provided in the laboratory. And for micrometer screw gauge, the uncertainty will be 0.01 mm, and for traveling microscope, the uncertainty will be 0.01 mm. And if we have digital scale, then our uncertainty is plus or minus the smallest unit on the digital scale. For example, this one will be 19.16 plus minus 0.01 volt. For this one, we are going to write it down as 13.8 plus minus 0.1 volt. Okay, so for this electronic balance, so the uncertainty can be read up to 0.01 gram. For this one, it can be only read up to 1 gram, the smallest unit on the digital scale. So here is a table as a guideline for you that you can refer from time to time to note down the sensitivity and the uncertainty for different or various apparatus that provide in our laboratory. So bear in mind, when you write the list of apparatus in report, goes to the measuring instrument in the list and write the range and sensitivity of the apparatus next to the instrument given. For example, if you are going to use a meter rules in a particular experiment, then note down the range and also the sensitivity of the meter rules. If you are going to use a timer, also you are going to note down the smallest unit that can be read from the digital scale. So in observation table, always include the uncertainties of the measuring instrument in column header. For example, we might always start with the physical quantity names, follow with the symbol, and then in bracket the plus minus uncertainty by referring to the measuring instrument we use and the unit. For example, I have height, h, and this height I measure with meter rules, so the uncertainty will be plus minus 0.1 and the unit is centimeter.